Bienvenidos, Ushamdi, and welcome CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course by Cisco Networking Academy, and this afternoon's video tutorial and solution set is going to be on Packet Tracer Activity 4.1.1.11, where we're now going to be taking our second look at extended IPv4 ACLs. And this activity is going to be a little different than the first activity in the sense that we're not really given all of the commands that we need to run. In this activity, what's actually going to happen is we're going to be given requirements, and then we're going to be asked to go ahead and come up with our own ACL. And so when we take a look at the activity here, we can clearly see that there's a lack of commands that we saw in activity 4.1.1.10. Now, the topology is a little bit different, but it looks like everything is going to focus on router A here. And so we've got our addressing table, and we're going to configure and apply and verify an extended numbered ACL. So here are the requirements. SSH traffic from devices on the 10.101.117.32/28 network. So SSH traffic is allowed to get to devices on the 10.101.117.0/27. So in other words, what we're saying is the first requirement is that traffic from this network here, if it's SSH traffic, should be allowed to go to that network. Now, the second requirement that we see here is this ICMP. So traffic is allowed from any source to any destination. To any destination. And then all other traffic to the 10.101.117.0/27 should be blocked. So when we look at this, it really looks as if it's going to be 3 ACEs, or access control entries. We're going to have one to allow the SSH connectivity. We're going to have another one to go ahead and allow ICMP traffic, and we're going to have that third implied. Remember, we're not actually going to have to configure this because that is the default. So by default, we've got that deny any at the end of the access control list that's going to sort of be our garbage collector. And so anything that we don't explicitly permit is going to be implicitly denied. All right, well, let's go ahead. Let me clear the screen here. And let's see. So configure the extended ACL. So we've got some additional requirements here. And this is going to kind of give us an idea as to what it is we're going to need to do. So let's pull up router A, because clearly this is going to be on router A, which is kind of the center point of the topology. And we'll bring this window down and we'll give ourselves a little more room to work. And there we go. All right, so we're on the command line, and our password is going to be Cisco ENPA55. We are connected to the console, so Cisco con PA55. So we're in user exec mode as evidenced by the greater than sign, and we're going to type enable to get into privilege exec mode. Here's where we're going to say Cisco ENPA55. So now we're in privilege exec mode. Let's get into global config. So from the appropriate configuration mode on router A, use the last valid extended access list number to configure the ACL. Well, in order to do that, if it's numbered, we don't start it with IP. We simply say access list, and I can quickly determine that the last number is going to be 199. It actually gives us the number there, but that's another way that you could check. Now, use the following steps. So the protocol is going to be TCP. So what are we doing in the first ACL? We're permitting, right? We're permitting TCP because that's the protocol that SSH leverages. So we would say access list 199, permit TCP, and now we're going to go ahead and let me take a look here. I got to look at these IP addresses, because the source network is, so we're going to do it from the network, it looks like, and that's what we did in the other activity. Now, we could just as easily do it for only the PCB, just like the other activity, but it looks like they want 10.101.117, at least the wording indicates that this is what they're going to be looking for. Now, the wildcard mask can be determined by subtracting 255, 255, 255, 240. In other words, the net mask in dotted decimal notation from the all 255s. So they've kind of done the work there for us, and that kind of leaves some easy picking there to get the answer. So the wildcard mask is going to be 0.0.0.15. Now the destination network is 10.101.117.0. So we have our 2 network, and let's make sure that we get our decimal places in there in the IP address to divide the octets. So the destination network is going to be 10.101.117.0, and again, the wildcard mask, not too difficult to figure that out. We subtract from the all 255s, and we end up with 31 in that last octet position. So now that I have the from, which is my 10.101.117.32 with the wildcard mask of 0.0.0.15, and the 2, or the destination network, I've got the 10.101.117.0 with a wildcard mask of 0.0.0.31. Now I need to specify, we're talking about SSH here, so this is where I would say equal, and I would end up picking either the mnemonic, like www, instead of typing in 80, or for SSH, what could we put? 22, because that's the port number that the secure shell is using. All right, so that is the first ACL statement. Now we're going to move on to the second ACL statement. ICMP is allowed, and this is actually pretty straightforward. So again, it's going to be access list 199. 199, permit, and we're permitting ICMP. Now, this is from anywhere to anywhere. There really isn't a more specific requirement given. It literally says ICMP traffic is allowed from any source to any destination, right? And we don't get any more specific information. Are we only allowing echo replies? Are we only allowing the TTL exceeded? So again, it's just all ICMP is going to be allowed. So then I'm going to go ahead and I'm going to hit enter. Now, and you can see we were just given 60 points for that. So those are the only 2 statements that are required. Remember, at the end of the ACL is the implicit deny any. In other words, we don't have to say access list 199 deny, and here's where we would literally say IP any, and that's all I would have to put, right? But that exists already. We don't see it because it's implicitly there, right? So remember, if you don't explicitly allow something, it will be implicitly denied at the end of the ACL. And now we're going to do this. I think this is pretty straightforward activity here. Let me clear the screen, get that red line out of there. So this looks pretty straightforward, and then we're going to have some validation activities. So we're going to now go ahead and apply the extended ACL. So, and this is interesting, the general rule is to place the extended ACL as close to the source as possible. So if that was true, where would we put it? So remember, that's the source network that we're talking about with respect to SSH, but not with respect to ICMP, because we're saying that anybody can use ICMP. So here we could see, and I'm drawing with my mouse, I apologize, ICMP, right? Where you could have PCA. We want PCA to be able to ping up here to the switch C network. So if I put the ACL here, right, PCA would be able to ping through, but the problem would be is they'd also be able to SSH through. They'd have, you know, free reign here. And the requirement, again, is that SSH traffic from devices on the 10.101.117 network is allowed to these devices. It doesn't say that that network is allowed. So we know that we can't put it here, right? We know that we can't put it there because then while that guy can do everything he needs to do, this really isn't the optimal location, right? So the optimal location would be placement here. And so as I commented in the previous video, and we talked about that best practice, right? That general rule that if you can get the standard ACL as close to the destination as possible and the extended ACL as close to the source as possible, that's the best case scenario. Now, if you can't, right? Those again, they call it a general rule, a recommendation, a best practice. But if you can't do that, and this is a great example of where it doesn't make sense because that putting it here, right, is going to be blocking. It's only going to allow SSH and ICMP, but it wouldn't even allow SSH for this network, right? So again, it doesn't make sense to put it here when this is the network that we're trying to allow through. Although, if we did put it here, remember, the PCA is not going to be able to SSH through. But they would be able to ping through. But that is not the best location. The best location is here, as close to the destination as possible. In this case, because of the requirement statement. Because the requirements are saying that SSH traffic from devices on this network, right, are allowed to SSH to devices on that network. And so what if we plug somebody else in over here, right? And if we put it there, we've got these guys coming through, and then these guys would be coming through. If we put it here, you'd have the traffic from there, but if we connected something else up, we'd have an issue. So this covers the use case that we want, is we want it on gig 02. So let's do this. Let's clear the screen, and let's pull router A back up here. Let's get into interface gigabit Ethernet 02. And now the question is it going to be in the, so let's first we'll say IP access group 199. Now, is it going to be inbound or outbound, right? Are we going to be blocking the traffic as it exits, or I should say filtering traffic as it exits, or is the packet filter going to be filtering it as it comes inbound to the router A gig 02 interface? Yeah, exactly. It's going to be outbound, right? Because if we're talking about traffic coming from here and traffic coming from here, those two sources are both going out of the gig 02 interface in order to reach this network. And so we want to apply it on the gigabit Ethernet 02 interface, and we need to apply it in the outbound direction. And let's see if that is what the activity was looking for. All right, it was. What is the command? And so we've got that in there. It's IP access group 199 out. So if I say do show access list, let's take a look at our access list here. And you can see we don't see any hits of any kind yet, but let's do our validation. So we're going to ping from PCB to all of the other IP addresses in the network. And so let me pull the, and I don't know if we'll do all of them, but we'll certainly do some of them. So let's get our command window up here. And so now let's validate. So can I ping to switch C? And switch C's address is 10.101.117.2. And this should work, right? Because remember, we were allowing, and we'll probably have one timeout here. And did I type in the right IP address? 10.101, there we go. Okay, I did. When it pauses like that, it always makes me think that maybe I put the wrong IP in. All right, so the right IP is in there, and we've got connectivity. Now, from PCA, can I ping switch C? So let's give it a try. So ping 10.11 or 101.117.2. And so those ping requests are being allowed to go through. So now from PCB, we're going to try to SSH to switch C. So we're going to say SSH -L, and we're going to go in as admin 10.101.117.2. And we get prompted for the password, admin PA55. and now we're in switch C. Let's try that same thing from PCA. Remember, PCA's network is not covered by the ACL statement that is permitting SSH access. Oh, sorry, so we're going to say SSH minus L, and then admin and 10.101.117.2. And as you would suspect, we're not going to get connectivity, right, or a connection. We're going to get connection timed out, remote host not responding, which is different than connection refused, right? This is telling us that the connection timed out because, again, we're sending those TCP-based packets, but they're being blocked or filtered once they hit the gig 02 interface on router A. So as you can see, and let me take a look here, we tried the SSH. Oh, wait a second. So they've got a question down here, and let's see what they're asking. How was PCA able to bypass the access list and SSH? Hold on one second here. I think we've got something else to do here. Oh, okay. All right. So they want us to SSH from PCA to switch B. All right. So we'll play along here. So we're going to SSH minus L admin and switch B is 10.101, 10.101.117.34. And so we got our password, and the password is admin PA55. And so here we are on switch B. So if I try to go from user exec to privilege exec, it should be Cisco ENPA55. All right. So if I was to say show IP interface brief, and we don't have a good breakdown here. Let's see what we've got. So VLAN 1 is being used as the management VLAN because that's the VLAN that is assigned. This is a switched virtual interface. And so what's going to happen if I say show run, we should have a statement on this switch, and that's why I'm going to say show run. We should have a default gateway statement on this switch that's pointing to the gig 01 interface IP address here on router A. So let's see if we've got that. And that's what it should be pointing to, although sometimes Packet Tracer will point at odd, and there it is, right? So, and this is a very important concept here, right? Because what this is saying is that for management plane traffic, and when we talk about the management plane, we're talking about traffic that's generated by the device, not the traffic that is transiting through the device. And there's a big, big difference. So this IP default gateway statement on the layer 2 switch, right? That's a layer 2 switch right here. That IP default gateway statement is basically telling switch B that when, like we are right now, when you are generating the traffic, and maybe it's ping traffic, right? So if I'm trying to ping 10.101.117.2, right? That traffic right there, since it is not destined to something on switch B's management VLAN network, which is this 10.101 117.32/28, right? And that's our IP in VLAN 1. This is basically the equivalent of setting the default router on a PC, right? Because we have to tell the switch that if you're sending traffic, right, if you're generating management plane traffic and sending it to a node that is not on the same network as you reside on, this is your default router or default gateway. It's the equivalent of this when we look here on the PC, the default gateway right there. Right, so we do this on the PC and we tell the PC that's your default gateway. We're basically doing the same thing here for the switch because remember, this is a layer 2 device. We are not running a routing protocol. So we have to help it and tell it this is how you get to your default gateway, switch B. And so for traffic that switch B is generating, that's how it knows how to get off of its local management VLAN segment to other nodes. And that conversation that we just had right there is important in this context, because what did they ask me to do? Excuse me. They said log into switch B and now SSH over to 10.101.117.2. So we're doing an SSH connection from switch B. And the question that we get asked on the bottom, and you can see there, I'll say admin PA55, the question, and now we're on switch C, the question here is how was PCA able to bypass the access list 199 and SSH to switch C? And the reason for that is because first we went from PCA, we SSH'd to switch B. And then we initiated the connection from switch B to switch C. And so that's how we circumvented not allowing this network here, this top network PCA switch A, that is how we circumvented the ACL, is we simply went from A to B, and then from a network that is allowed by the ACL, we went up here because the source address of the request, and remember, we've got a packet filter, and I can't stress this enough. Packet filters, ACLs, that we're using are packet filters. They are stateless, and they are simply looking at the layer 3. In this instance here, since it's an extended ACL, we're looking at the layer 3 and the layer 4 information. So we're looking at the IP header, source and destination IP addresses, and we're looking at the TCP header, checking for the protocol. So that's the information we're looking at. So when I log on to switch B, as I did right here, and let me exit out here from switch C. So when I log on to switch B and I go to initiate my connection to the 10.101.117.2, when those packets show up here on router A and they go and they're being evaluated by my ACL, the ACL is going to say, oh, the source is switch B. So it's coming from the 10.101.117.32/28 network. And it evaluates that first ACL statement. It evaluates it, looks at those packets and says, yep, those are allowed through, and it allows them to come through. And that is why we were allowed to bypass the ACL, because we came over to switch B and then made router A think that we were switch B, because that's where we're coming from. All right, so what could have been done to prevent PCA from accessing switch C indirectly while allowing PCB SSH access? Well, there's a couple of things that we could have done here. So the first thing that we could have done was we could have placed an ACL on gig 00 that denied SSH connectivity to router A and anything over here on PCB switch B's LAN, and then permitted everything else. So that's one way we could have done that. So let's go ahead and let's do that right here. Let me go ahead and clear the screen. So instead of talking about it, let's do it. Right? So here we are on router A. So, oh my goodness, we got caught with the Cisco Con PA55. There we go. So we're in user exec. We use the enable command to get to privilege exec after we type in Cisco ENPA55. So we're in privilege exec. We go global or config terminal to get to global config. And so let's do another access list. So I'm going to say access list, and we're going to number this one 100. So we use the last available number for our scenario. Now we're going to use the first available number. So I'm going to say access list 100, and I'm going to say deny TCP. Now I need to be careful, right? Because I only want to shut down SSH And you know what? We'll throw a second one in there to shut telnet down too. So I'll say access list 100 denied TCP from what network? You've got it, the 10.101.117.48, and that's the network up there. Now, we're not given this information, so let's employ one of the two methods we talked about in the previous activity. Well, we see the CIDR notation, the classless interdomain routing notation here. We got a /29. So we know that we've borrowed some bits, and how many host bits remain? Right? There's only 3 host bits that remain. The preceding 29, and I'll just real quickly say these 8 bits dot, these 8 bits dot, these 8 bits dot, and then what do we have? 5, and then those 5, that these are all the network bits. So they would all be ones, right? A whole bunch of ones in here. In fact, 29 ones. So we're left with 3 host bits. So if we use the binary method that we saw in the previous activity, we just simply go 1, 1, 1, right? And then we sort out what these values add up to. Well, it would be 1 plus 2 plus 4. So it would be 7. Or if I looked at this and I said, it's a /29, what would be the dotted decimal notation for a /29? Well, the first 5 bits are taken, so it would be 128, 192, 224, 240, 248. So if I was to subtract 248 from 255, what do we end up with? Yep, so 0, 0 after we borrowed out there, and 7, so 007, right? But again, it's just 7. That's what we end up with. So what would our wildcard mask be? It would be 0.0.0.7. So those were the 2 ways that we saw when trying to determine what is the wildcard mask value going to be. And this was kind of nice, right? Because I don't know if we were ever provided that over here. We weren't. Okay, good. So again, it's always nice to sort of do things outside of the box where we're kind of not being prompted and given the values. So that's going to be my wildcard mask. So I'm going to leave that up there for right now. And we'll come back down here and I'm going to say 0.0.0.7. So remember, I'm denying TCP from that network where? And let's do this. I'm going to say I'm going to block it going anywhere, right? So no TCP connectivity, no TCP connectivity is going to be allowed. If I were to hit enter right now, that's what we would have. However, remember, what did we say? Yeah, we want to block SSH and we want to block telnet. So we deny those 2 things. Now, if I stop right here and I go and I apply this ACL to that interface in the inbound direction, remember, this is going to be a use case where our extended ACL is going to be placed as close to the source as possible, because this is the network we're trying to impact here, and that is going to be the appropriate place to place this ACL. So if I applied this right now, will I be able to ping from PCA anywhere? Because remember, did I block ICMP? No, I didn't block ICMP. So am I going to be able to ping from PCA to anywhere? And you can probably tell by the inflection in my voice that this is kind of a rigged, trick question. And the answer is no. In fact, if I was to apply this ACL right now, PCA will have no connectivity to anything via any method whatsoever. And why is that? Because at the end of every access list, 100, there's a deny, in this case, a deny IP any. And remember, it's implicitly there at the end of every ACL. So let's do this. Let's make this interesting. So let's say that we forgot that rule. So I'm going to go into interface gigabit 00, and I'm going to say IP access group 100 in. So let's test real quickly again, real quick. So from PCA, and we're still over here on switch B, let me ping 101.117.2. So can I ping switch C right now? Looks good, right? All right, let's apply our ACL in the inbound direction. And now let's pull PCA up and let's see if I can ping. Yeah, destination host, not a timeout. Remember, this is what we see when it's an ACL that's responsible for blocking the traffic. So now I can't ping host C. Can I ping B? Let's see if I can get back over to B, 10.101.117.34. No. So everything is being blocked right now, and it's being blocked because we overlooked that implicit deny any at the end here. So in effect, it's great that those two statements are there. They're certainly going to stop telnet and SSH. However, there's the implicit statement at the end that's basically blocking everything else. So we have cut PCA and switch A off from the entire network setup. So this is a good, little outside the box activity. How do we fix this? Well, let me say do show access list 100. So those are my two statements. Well, remember, it's a numbered statement, so how do I change it? Can I just throw another statement in there, or do I put it at the beginning? Do I put it at the end? Well, I could say IP access list 100, extended IP access list extended 100, 100. And I can go in here and now I could put some, if I wanted to put the sequence number in there, I could do that, right? Or since it's going to be the last visible line, the last explicit line before that implicit line, the last explicit entry, access control entry that I'm going to put in there, since it's going to be, I'm just trying to pull this back up, since it's going to be the last line, I can simply go ahead and say access list 100 permit IP any. And so now when I say do show access list 100, that's my last entry, right? So now I've updated that ACL. I realized the mistake that I made. I now go back. Can I ping PC? Or I'm trying to ping from PCA to switch B. So I can ping switch B. What about switch C? Absolutely. But let's get back to those reflection questions. What could have been done? Is this going to prevent me from saying this? SSH minus L admin to the 10.101.117.34 is switch B. So can I SSH over to switch B and be sneaky and circumvent the ACL, preventing people on the switch A LAN from accessing the switch C LAN components? And it looks like we're successful here. So as you can see, connection timed out, remote host is not responding. So we'll come back over here and we'll say do show access list 100 and take a look. There's those SSH connections. I have 12 matches showing that that's been denied. We had 8 matches showing because I pinged twice, and the Windows host is doing 4 ping packets each rotation or each iteration. So those are in there. What about telnet? So if I come over here and I say telnet over to 10.101.117.34, you can see it says trying, but what should we see? I should see something right here to the right of the telnet keyword showing me that, hey, you've got matches here, right? That someone has tried to telnet and, I'm sorry, I was looking at something else here. Yeah, someone has tried to telnet and we see how many attempts are being made, or how many packets have been matched, I should say, because obviously there weren't 12 attempts made there, but these are the packets that are being matched. All right, well, this is going to wrap up Packet Tracer Activity 4.1.1.11, where we took a look at taking requirements, constructing an ACL to meet those requirements, using multiple access control entries in the ACL. And then we looked at some other questions, right? We looked at, well, what happens when switch A figures out a way to circumvent getting over to switch C? by coming to switch B first. And we talked about how we would sort of prevent PCA and switch A from being able to do that. So again, the key takeaways, remember, when we're talking about ACLs, these are nothing more than packet filters. They're not stateful, right? There is no statefulness about an ACL, okay? Especially when applied in this context, right? There is no stateful information being kept here. They are stateless. And last but not least, we looked at the different numbers that we could use, and we were using extended ACLs, so we were matching on layer 3 and layer 4 information. All right, guys, thanks for watching, and I will talk with you soon.